Hello.
Hello, hi.
Hi, how are you?
Good. Hello.
How are you?
Hi, Alicea.
All right, how are you?
Vidhi. Should I go first or Vidhi gonna?
I think you can go first. Yeah.
I don't mind.
This week there are quite a lot of things to discuss. So first I'll start off with visualization techniques which I have been reading, and I have concluded that okay, one is good. I mean, like a certain type of visualization could be good, and I've plotted them. So first I'll give a introduction about the visualizations. So what kind of visualizations that we can see to have these hypergraphs? So one is like Euler volume or 3D Venn diagram type of visualizations, or we can use paint splash, which is similar to that of the kind of clay or something types of. And when we see in a mathematical way, we have these convex hulls, and whereas the Zykov type of or clique type of expansions where we see like cliques forming exactly in a graph manner, and we have a extra node of star type of expansion. So a star is basically more like it looks like connecting all the nodes using lines, but it has the same commonality. So 3D 3D Euler diagram looks like this. It overlaps by using these edges. So here we can see node V1, V2, V3, V4, V4, V5, V6, and this is V7. These are the edges that we drew. This is one way. So in the plane splash, so we have splash around the node. So we say that this edge which carries the different type of nodes here, or the hypernodes we say. This hyper edge is basically looks like a plane splash. But whereas this clique starts from node is perfectly visible, but the edge is more often like connection or a kind of triangle or a kind of a certain connection where it has end nodes are very pointed, and the edges are more of starting from that node. And the star node or the star expansion or extra node expansion is, so we have nodes V1, V2, V3, and we have a common edge E1 per se. So this edge actually carries the information of the V1, V2, V3. This is visually perceptible, quite good. And so when we think about the characteristics of these visualizations, so one is we can see the Euler diagram. So the pros of this is like it's very intuitive, overlapping, and it has direct volumetric impact on saying that okay, this edge carries some information, and we can make it look like, suppose it's a weighted, then we can make it look bigger and smaller and all. But the major disadvantages is when we scale the graph or when we scale these hypergraphs, it will be cluttered. Beyond 3 to 4 hypergraphs, and when we have an extra data later on, and in the long run, in the temporal, suppose we are keep adding the data, then the data handling is quite poor. The second is paint splash. So in this paint splash, it's like a smooth turnable hulls, we can do it, but the major disadvantage is it can have 10 hyper edges which are quite visible, but when it grows more, it actually we have a more number of hyper edges, then probably it won't do it. So and the data handling is also poor because it's not as very poor, not as bad as Euler, but it's comparatively little poor, closer to that of Euler. Whereas clique type of representation or Zykov type of representations, this can scale to so many edges. But the major disadvantage is when we have a dense set of regions, the identity kind of gets overlapped, and it's loses its set identity. When we say the set identity, we say its uniqueness. Suppose we say this has there's a unique edge between V1, V2, V3. When there are dense regions, they might get overlapped, and we lose the actual identity. Whereas the extra node or the star type of expansion, we do not have any of such problems. We have when we try to render it onto the interfaces, we'll have a little heavier cost compared to these, but this actually carries a true hypergraph structure because it actually connects all the points, and it does not have any specific weight component to visually look into that, but it can handle the extra data quite well. So let's actually jump into the visualizations that we have created using our Python code for the data that we have. So I actually push the code and probably I'll show it. So this is the data which I have used, which is like the cell birth and time position data. So yeah. So first what I tried to do is I did a star expansion of the graph. So where I represent a triangle as the hyperedge and the nodes, hypernodes as like simple blue color. So here we can see this is a static graph. This does not have any interaction. So it simply gives us information that this is a purple color node, I mean like hyperedge, which has a common, it's connecting so many, nodes, hypernodes. So this is one way of representing. But this is, as we have previously starting from, we have moved from like static to like dynamic and interactive hypergraphs. So what, for the same graph above, this is the same graph. This is just an example. I've just plotted it. So we can see how the hyperhedges are distributed. So this is hyperhedge 1 and see the connections it has. So now we can definitely say that, all these hypernodes, the purple ones, are connected to that hyperhedge, which is the represented in a square format or maybe in a diamond type of format. So this is hyperedge 1, hyperedge 2, 3. This is just a random example. So just to see that how does it look and all, I just plotted it to see like the behavior of this. And here when we put it on the tray, we'll get the trace if we touch the edge, and when we touch the node, then we will be able to get what node it is. We say suppose this is ABA, and when we touch the hyper node, hyper edge, we'll get what kind of sequence it carries. So this is like, I just randomly wrote code. This is not for our data. So what I've done is I tried plotting for the entire data. We have the cell division hypergraph, right? So when I plot it for the entire data, so it looks like this. It's quite cluttered, but maybe we start like this. So these are all the entire sequence of data that we have. So when we zoom in, so we will be able to see how are these connected. So how are these, this hyper edges are formed is, I have taken the parent cell and the two divided daughter cells. So suppose this is the parent cell, A, B, P, R, P, A, P, triple A. And so this is the birth time it has, and it is divided into this and this. So like that, we were able to get the entire sequence data. This is not, this is very much cluttered, and it's quite not intuitive. And, we have to zoom it a lot, and, we have to see like where exactly, I just lost it. Yeah. So we have to zoom it and we have to see where exactly the locations are and all. And this is quite cluttered. So what instead I've done is, I have taken a certain birth times. Say like 0 to 50. Let us see how is the behavior. So here I'm able to see like from 0 to 50. So it starts from like P0 and birth time 0, and it divides into here P0, and it's divided into P1 and AB. So from AB, it is, this is again divided into ABP and ABA. So what is the information it carries at birth time 17? So this is quite a good intuitive visualization. So this is birth time 0 to 50 and 50 to 100. So what are the things extra they have been expanded? So we can able to get, so from this, here it can identify, if we double tap on this, it will say that, okay, this is the information that we have. Suppose we double tap on this, we'll be able to get the information that it has. So yes, so this is the visualization part that I've worked on. And additionally, I've been looking into some of the details of how the synthesiums and what is the behavior of the data that Nikhil Bhatla has shared. So, but for this week, I pushed this code, and this is what I have done. In the next week, probably what I'll try to do is, so this is what is the behavior of the entire data that we have right now. But whereas I want to look into the, the details of, not just this data, but the hypergraph neural network which we have trained. It has a certain embedding space. It carries or it brings certain set of cells together, right? So if I make a hyper edge between those, how does it look like? What kind of sequence it forms, and what kind of synthetiums it forms, or maybe we'll be able to understand during the growth process which all cells actually come together, which all cells have a common pattern. So that maybe we can observe doing that. So yes, so this is what I've done for this week. So any suggestions?
Thank you. That was great. So in terms of the visualizations, are you going to pick one and move forward with that, or are you going to try to produce things for all four of them and have them as options?
Right. I've tried using the Euler thing, but it was very cluttered. I was unable to get any insights from like visualizing the Euler. I haven't tried the other visualizations, but the scalability factor is quite high for what the visualizations I have picked. So I have decided that, okay, when we are trying to do it in the long run, and when we are trying to visualize it in the long run, I believe that what I have used is more of scalable approach. So that's why I've picked this and moved forward with this visualization. So I currently do not have any method in mind, but probably I can implement them if we think some of it is interesting. But this was quite visualization which is quite intuitive and both easy to write the code upon. So remaining all, we have to use some other rendering technique tools, which probably I have little knowledge and exposure to. But so this was quite easy to, because I'm already hands-on with Python, and that I was able to do. So
okay, well, that looks great. Yeah, I like the way you've been able to visualize the entire embryo, or up to a certain point. So
right.
It looks good. Yeah.
So I actually made the entire code available, so it's quite easy plug and play. We can get all the visualizations.
So this is on the GitHub. This has been pushed.
Yes, I have uploaded on the DevoGraph. This here. I haven't written the README file for that, but I just uploaded the code and
okay,
made sure that it's quite reproducible.
Yeah. Yeah, so we should be able to do the README, I think, later. But yeah,
right.
That's good. All right, well, thank you. That looks like a great update. We'll have to explore that a little bit and see. So what are your plans for the upcoming week or two? What's your
So upcoming week, what I'll probably do is I'll try to, so the neural network which I have trained, the hypergraph neural network. So I'll try to get this neural network tries to understand, brings a certain hyper edges, the hyper edges which are closely proximately and lineage level related, they'll bring together, right? So that edges I'll try to able to visualize using this approach and see what is the network dynamics. What are the, what kind of topology that our network carries in order to understand the developmental process. So I'll be able to visualize using this approach because this is more intuitive. So that is my thoughts, for the next week. And I have analyzed a little bit of, the data for the Nikhil Bhatlas. If you have little time, probably I can discuss.
Yeah, I mean, do you want to do it now or?
Yeah, I have a quick few updates, okay. And maybe I'll do it in detail later in DevoGraph group probably.
Okay.
So right now, I see, this is what previously what we have, discussed. So we have hypodermic 7, 6, 4, 5, 3, and hypodermic 1 DL, DR, VV. So these are what we have found. And I have did a timeline analysis because Richard has, suggested some insights which I got. where I was able to see that in early or 0 to 500 minutes of the embryonic development, there were like 41 events, out of which, most of the, other than hypodermic 7, most of the syncytiums are formed at very early stage. And I've seen that, in mid and late and post embryonic, it was more of hypodermic, syncytiums that were hypodermic 7 syncytiums have been formed. So, like the events initially were like higher in number and then drastically come down during the mid, and during the late they have again increased, and during post embryonic, and they were like like they're little more than just the mid. And I have a detailed visualizations for that. Here we are able to see that I have used the same color palette which I've used for each of the syncytiums here. So here is the frequency that I'm trying to understand in the first diagram. So the frequency in the initial 200 to 200, 300 is quite high. And again, the frequency comes after like 1000 minutes. And again, it comes under 1800 minutes. So I think there is a pattern I observe. This happening at a certain time event. I am not really sure why this happens, but I less intuition about the biology, but I believe there is something pattern that's happening, so that we can use probably hypergraph to visualize them and see that what's the behavior happening at these time scales that can actually help us understand why these syncytiums have been formed only at that particular time, and what are they responsible for, and how are they helping the the embryogenesis or the developmental process. So yes. So this I've taken little from Sulston and got little from the internet pages and all. But yeah.
Oh, great.
So
yeah, you'll have to show us more on that on Monday at DevoWorld.
Yeah. Yes.
Right.
Okay.
Great. Thank you, Liv.
Thank you.
So Vidhi, are you ready?
Okay, so back to Sustain Hub. And so for week 7, we have crossed the midterm evaluation phase now. I think today is the last day, 18th of July. So I'm done with the Q learning and SALSA part, and I had already started with implementing the harmony index. So this week I have gone ahead and implemented the resilience quotient. So these were the outputs from week 6, that after every step we had the harmony index calculated using the formula from the paper that I had referred to. So now in week 7, as I mentioned, I have implemented the resilience quotient. So basically the resilience quotient is a metric to evaluate the system robustness, or it quantifies the drop or the recovery of a system. So it ranges from 0 to 5. So basically what is happening is that if there are multiple agents, or multiple contributor agents, and if in the middle of some phase they drop out, they stop working, so obviously we can't assign tasks to them, right? Imagine we are assigning the tasks and they completely they keep on skipping the task. That means they have dropped out. So we completely take that into account, and then we calculate the resilience quotient from that. So now why it matters is because it actually captures the real world failure scenarios, because not every agent is very perfect and keeps contributing. So that's why the resilience quotient matters. And yeah, it just reveals the system's ability to self-heal and what will happen if that agent is not there. So that's the significance. Again, I think these points are just getting repeated, that it evaluates the real world robustness and goes beyond the performance metrics. So yeah. So how we calculated it, it's kind of similar to how we calculated the harmony index from the same paper, that there's a utility and then we have alpha 1 into utility 1 plus alpha 2 into utility 2 and alpha 3 into utility 3. And the summation of all these alphas is equal to 1, like 0.4 plus 0.3 plus 0.3. And these 3 are the utilities, or whatever we have taken. So I have taken TRE, which is task reallocation efficiency, which measures the ratio of the total reassigned tasks to the total drop tasks, we have the success rate recovery, which is 1 minus the current success rate and 1 minus the difference between the current success rate and the previous success rate, and then the harmony stability, which is the difference, like which is 1 minus the current harmony index minus the previous harmony index. So after each step, these are calculated. So this is the output for this week. So for example, we are at step 6 and then we have a few agents. And okay, so like from step 5 to step 6, these 2 agents have dropped out. So we have like from the original number of agents, we have 2 less agents, and then some tasks are allocated to them, and then they complete it. And then again, it goes to step 7, and again, for example, in step 7, again 2 more agents leave. So it keeps calculating like that. And obviously, since I have only 15 agents, it can't work for more than 7 steps, because at the 8th step, we will have like a negative agent. So to deal with this problem, I will have to increase the number of steps. I'll have to increase the number of agents. So I've tested it out for a smaller count for now, and this is what we have. So it is still calculating the harmony index and the resonance quotient. So this is the output. This is a continuation of what happened last week. So the format of the output is the same, that the success rate will be shown on this graph, and the darker the color is, that means it has a higher success rate, and like if it's close to 100, it's darker, while if it's close to 0, it's lighter, or just yellow in color, beige. Okay, so this is the harmony index, and after a few number of steps, it increases and goes beyond 0.8, but it never goes above 0.9 because that's like close to perfect. And we have the resonance quotient. So if the resonance quotient is close to 1, like if we see over here, if we maximize each of these, that means the resonance quotient is high. That means it has a high task reallocation efficiency, success rate recovery, and harmony stability. So if it is high, that means the system is recovering well, and if it is low, that means it's not doing really well. So we can't have it. We can't have like if we see this graph, it is quite like a straight line, not a straight line, but it has some sort of average, or we can say that the value is somewhere between 0.8 and 0.9. But we can't say the same for resonance quotient, because it keeps on changing. Like earlier it's close to 1, or like in the first 2 steps it's 1, but then eventually it increases because it learns how it is supposed to reallocate the tasks, and then it gradually reduces a lot. Like this is not a gradual, like this is a steep down, and then this is kind of gradual, but it reduces because the number of agents over time reduce. So I had the blog, but before I get onto the blog, I want to share the output properly. So this is what I have. So this is like, for example, for the first run, I wanted to speak about the outputs from last week as well, because Sarah had asked. So for example, you run it for the first time, and then it has its success rates and the harmony index. So the harmony index for the first run is not around 0.8, or it's not a straight line, but it's kind of increasing. That's because it's still learning and it's still the exploration phase. Eventually, like once more and more agents are involved, they do more tasks, and the harmony index increases. So this is what is happening in step 3. So the harmony index has finally started going above 0.8, and here more agents are exploiting. So exploring reduces, and then exploitation starts, and this is what is happening. And then eventually, after a lot of steps, we can see that it's not really just 100% or 0, but we have a lot more, like a lot more success rates. This is the harmony index. And yeah, then we see that no agent, like there are very few agents for like very specific tasks that have not done anything, but usually they do. And yeah, this is the harmony index. So then when the resonance quotient comes into picture with a lot of steps after the harmony index, we have a lot of exploration and exploitation. So this is the harmony index. So the harmony index increases and it goes above 0.8, which is a good number. And so for example, if we start with the resonance quotient, then this is what is happening in the system right now. For the first run, we don't have all the agents because in the first run itself, for the first 2-3 steps, two agents keep leaving. So again, the harmony index over here is not great because it's the first step. So it's just exploring and then experting. So it starts with 0.4, and then eventually it increases and it gets better step by step. So over here we can see that there are a lot of 100% and it's a lot of exploitation and not exploration. But then as the agents drop out, we can see that we are also having exploration going on because the agents drop out. So we need to allocate the tasks to some other agents. And I think, yeah, like after a lot of steps, we come to this where it has a good balance of exploration and exploitation. And this is the harmony index. And okay, yeah, like a few more steps. We have the graph, and then the harmony index, and the resonance quotient. So for 7 steps. So at a time, I've visualized only 7 steps, but then if I keep running, then I can have more steps involved. And one sec. Yeah, so this is my blog for week 7, and yeah, that's it. Hello.
Yeah, thank you. Did you want to go over the blog post, or because you wanted to submit this to the lab medium?
Right, yeah. So I had contacted all of you guys about the blog post. So, like, I'd seen that last year, Sarah had put a blog post for her midterm evaluation and her end term evaluation on Medium. So, I wanted to do the same. Like, I wanted a blog post to be there on the orthogonal labs Medium. So, I wanted to ask whether my current midterm blog is good enough, or like what changes can I have in it.
Okay. Yeah, just submit, like I said, get your own Medium account, post it there, and then submit it to our blog.
Okay.
And you'll have to send a request, and then we can review it, and it should be okay. There may be some small changes, editorial changes need to be made, but
Hello.
yeah.
I'm sorry, I lost my net.
It's okay.
Yeah.
All right. Did you want to go over your post real quick, or did you?
I mean, yeah, okay, I don't mind going over it. Yeah, so this was the midterm evaluation blog. I think I ended up making it too detailed and too big. So I was just worried. So I've started off with how my journey was and what exactly SustainUp is and what it contains, like the multi-armed bandits, SARSA, and it's basically agent-based modeling and what like rewards. It's something about rewards, and that's how reinforcement learning works. So I was just giving a recap of each of the weeks. So obviously week 1 was just about how I had the whole environment set up, about how there were bug fixes, feature requests, documentation updates, and the dynamic task queues, and how the tasks will be allocated. And I have named the agents, the contributor, innovators, knowledge creators, maintainers, and the agent attributes, which are like more detailedly mentioned in the code. So that was about first week. Then in second week, I have actually introduced to like the multi-armed bandits and how we will use it. So the multi-armed bandits problem is explained, and then how the multi-armed bandit framework will be a natural fit for our problem, which is the open source software. Open source sustainability. So like the agents are the levers and the tasks are the pulls. Like how it happens in the multi-armed bandits. So I've attached a diagram to it that these are the agents and these are the tasks that the contributor agents will have to do. Then I have added about how in week 3 I have optimized the multi-armed bandits and like specialization that like this is just for an example that the innovators were found to complete 70% of the feature tasks and the curators were high with the documentation successes. So each of the agents were doing their respective tasks. So I have added something about Thompson sampling, which I've again used. This is the math behind multi-armed bandits, that theta is approximately equal to like beta successes plus successes plus 1, comma failures plus 1. And like that is how it is being calculated, that if it does the task, then it's a success. And if it chooses to do the task but fails, then that is how we are basically calculating the success rate. So the success keeps getting added after each step, and failures, like it depends on what the agent does in each step. Then finally, week 4 had the state action, reward state action, that is SARSA. So like real reinforcement learning, like multi-armed bandit is just like a mini version, but SARSA is what we have used and how it is going on. So the equation, and I have explained each of the terms in the equation and how it is, and the same reward summary, that if like contributor is supposed to do the bugs, so it's supposed to get a +3 reward for doing it, -1 for failure, and 0 if it skips, and +1 for any other task that it does, and similarly for the other agents. So I had explained the reward system. I attached a picture of my, like a screenshot of the outputs, that, for example, they are the agents, whether they are classified, unclassified, or if they are classified, then what kind of agents they are, and which tasks they do, and what success rate they have. So the same thing that I've been showing in the meets, and how the Q values are being stored. Then week 5 was about the scaling and persistence and improving basically what we have done in Salsa. So yeah, basically what is going on in the queue table and how we are storing it, the TK schedules. Then the graph that I had introduced, which I have been showing since the past few weeks. So at that time we had only 10 agents. So I put the one which we had for 10 agents, where we are showing which agent is good for which, like which agent is having how much success rate for which task and what their expertise is. And then yeah, about week 6, about how we have the harmony index and how we are calculating it. And I think I have added, so I've added the graph where it is going, like it's slightly increasing. So this is obviously after a few steps, just like over simulation over steps. And then I have just ended it with what I've achieved so far. The impact metrics, that we have 68% exploitation and 32% exploration. And yeah, approximately 83% task completion. And that's it. Yeah, like something about what challenges I've faced and how I tackled them, and what I'll be doing next, like the metrics and shaping the rewards again, transfer learning, human in loop, and one thing about like just final thoughts and how I have been doing this with oral under GSoC. So yeah, under INCF.
Right. That's great. Thank
Yeah.
you.
Yeah.
Yeah, I really do appreciate the fact that you're working on these different metrics, and you really have, I think, focused
Yeah.
down to testing specific metrics and getting them,
Right.
in the context of the model. So that's one thing I think that's really valuable here are the metrics for agents, just having those kind of
Yeah.
in code. Yeah, it's good. Thank you. All right, so that was Vidhi and Lalith, and Jayadratha will be presenting in DevoWorm this Monday. He contacted me and let me know about it. And then Lalith, also, if you could give an update during our DevoWorm meeting, that would be great too. Just on the, that you're working on the Centitium stuff. I think you wanted to present on that. So that's good. Looks like Morgan and Jesse are here. Morgan, are you around, Jesse? Are you around?
I'm here. I am at the water park in Southwest Virginia.
Okay.
In his cousin camp, and so I'm here with my younger kids and nephews. So listening in, trying to follow. We'll have a lot more updates. The open source 3D bioprinting workshop this week was amazing.
Oh wow!
Like super cool. What you can do. I mean, this is a way to construct your own microfluidic systems with a consumer 3D printer.
Okay. Wow.
So we basically we jailbreak the printer. We remove the plastic extrusion heads, replace that with a 3D printable syringe mechanism, and and then it's really about, but then everything you're doing is leveraging all the software that's available for, it's like we're using Orca Slicer, big open source projects, so the 3D printing community already has this kind of reliance on the open source community or open source software. And then the combination of that plus these kind of collagen materials and things that we're using are just amazing in allowing you to produce both a microfluidic system as well as a scaffold that you can really use to help guide development, right? And so it's like it's not just you don't need a clean room now to produce these microfluidic systems, but you can also create these like perfusible tissue scaffolds as well. So I'll share some pictures. We printed a few kind of test things, but we also printed their most recent, it's like matches a kind of serpentine microfluidic system with 2 inlets, 1 outlet. And anyway, super, super cool. And got lots more to say about it in terms of like what this group is doing in terms of producing, like a artificial, a printed pancreas.
Wow.
And some other things that they're doing at certain point it starts to become more about the kind of cell culture facility and kind of complexity that you can handle, right? But that's super interesting as well.
Yeah.
And there's lots that we can play with just in terms of looking at materials and looking at what's called 4D bioprinting. So, printing and then tracking development of things, and connecting it with a whole bunch of other projects that I'll be talking about, as well as the kind of CompuCell 3D simulations. So.
That's great. Thank you. Yeah, that sounds like that's all coming together, and that there's some really nice advances in technology. I wasn't aware that you could do a lot of microfluidic stuff now at a very low bar. Yeah. Now you're muted if you're wanting to.
No, just that was kind of that's what I've been doing this week. And I also got to interface with a lot of neuroelectronics groups that were basically in town to learn. I mean, they're also there at Pittsburgh. So Tracy Sue's group, like CUI, and so this is like well-established neuroelectronics or soft bioelectronics lab, and I think in terms of these collagen-based scaffolds and the kind of this technique of fresh printing, if we can get our neuronal cell culture, both infrastructure and protocols working, like there's some really exciting work that we can do. Everybody's telling us like the reason that nobody does neurons is that they will die if you just look at the neuron. So they're like, good luck with that, or tell us, tell us how that goes. Have fun storming the castle, I think is their kind of comment. But more to say next week.
All right. Yeah, that sounds great. Yeah. That's, I think, true of a lot of cell culture, depending on the cell type. But yeah, that's why they have like these workhorse cells that they culture specifically for experiments that they don't die easily. And then you have cells you want to culture that you can't because they die easily.
Yeah. So I'm still looking for. I've got some ideas about approaches that might might be alternatives that are interesting, but still, that still requires to have our full BSL-2 facility, but yeah, it would be great to connect to more cell culture, especially neuronal cell culture groups. But that was nice too, is that I really got to connect to some groups that are actually, have that kind of experience, even though they were potentially doing this for, different kinds of reasons. Not definitely not trying to grow brain tissue and stimulate it. But in particular, the group that was running the workshop, or whose work was the basis of the workshop, I've been really trying to connect, get him interested in Mind In Vitro. And so if we can combine his bioreactor with Mind In Vitro, I think that would be really exciting. And again, I can talk about some things that will actually make this a really viable project if we can combine these. Anyway.
Yeah, that sounds good. All right, thank you for the update, Morgan. All right, so Jess, are you there?
I'll share a few things. I don't think I'm going to do the full presentation today.
Okay.
That I mentioned last week, just because of timing. And there's some other things I want to say, and I want to just kind of go in depth on that when I do it. Yeah. So this week for me, things are going. I'll say more about data and direction tomorrow. I don't think any of those folks are going to join us this week, or Friday's kind of a tough time for everybody. So I don't know if they'll be that active in this Friday meeting, but the data and direction interns are doing well. It's nice to see them taking off and getting a little bit more into what we want to do. And it's definitely been interesting, because it's been a sense of I'm really trying to do things differently with that internship than most everything else, because everything's very tailored right now. And I don't think I'll do that forever, but it's a nice moving on the front. The main elements of this week, though, it's huge. It's been a huge week in terms of I don't know, something that's sort of the main stuff for this week has essentially been I don't know if I should categorize it as entrepreneurial or business or whatever side of things, but suffice to say, this one, it's been a really great week for a lot of things. I guess I'll start with this one. I think you can see that. I've been a part of this program for a few weeks now, and it's offered a lot more than I expected. So I'm not going to get into details here. I'm going to try to make a sort of a nice post about it. But I've met with a lot of strategic consultants. I've met with one of the courses, or one of the topics was accounting for startups, and just sort of this the nitty gritty unpleasant stuff. The talking to people that have been in the field for a while, talking to people have been in biotech, and they're doing this sort of the strategic components of what's going on, and just the exposure has been great for the program, much more than I expected. And there's a lot going on there that I'll speak about in another meeting, but I'm trying to push some things forward with essentially Joe Pro and some other things in terms of making a lot of these things come to fruition. So that's sort of a very vague thing to say, but it's been great content for this. I was also able to attend this, which is actually here in Boston, but I attended virtually, as you can tell. And this guy, a lot of background, he's formation venture engineering, which is sort of I don't know what to say about that, but it's sort of like thinking how would a venture or a startup or a project take off. He's a background in sort of biomedical tools, if you will, and some things that I'm familiar with from my previous line of work, or other line of work, I should say. But there's so many things this week in terms of just how to make a group, how to lead a group, how to do consulting, or whether or not it's consulting as in a paid job. How do you evaluate? Like this week for me has been so much on evaluating and understanding both business and administrative things, and like the functional leadership stuff in sort of the non appealing, the non sexy ways of it, because a lot of this stuff has been very in the trenches, in the nitty gritty versions of it. And one of the takeaways from this particular meeting with Gary at Ethos was, a lot of these things. When you find people trying to build a company or build a group or do something of the nature of, making something grow and develop, it's like, oh well, we really want to invest in the product, we want to invest in the team, but there's not always an actual legitimate focus on how the team is relating. And there was a very nice detailed discussion around, can the management, is the management dealing with fear or concerns in the right way, or are they sort of exporting that or outsourcing it back to the group instead of sort of the leadership role of trying to manage uncertainty and fear and challenges and conflicts like at that level. So that was one thing, and one of the other biggest things, which is very very interesting and kind of nice to hear, and this is sort of maybe relevant for those of us who are one day thinking about making their own company or joining a group or joining a startup, but it's sort of like being very mindful about how whomever your funders are, and there's differences in terms of like venture capital, or people who are angel investors or people that want to see your stuff grow, is sort of like the alignment both from the top down, if you will. Like, what are the disparate what are the potentially very different goals from people who want to support what you're doing and then what you want to do. And Gary did a very interesting job of saying, like, how can you try to get what are ways to get both the your co-founders or your co-funders on the same side of the table as you, as in you're both looking to get, you're both looking to go in the same direction, as opposed to very conflicting things where, well, I'm under pressure from my funders because they want to really extract a lot of wealth or a lot of opportunity, or make make the employees do all this, work very hard, overexert themselves to achieve a certain goal or a certain aim or a certain milestone. And then finally, the final point I'll make about this is like, similar to what I said about the CEOs or leadership handling fear or uncertainty, it's noticing that unless there's a certain healthy regulation in group to how things are done, over time, like once factions build up, because you have like the people that are being very defensive, the people that really want a certain product to go, like the more and more factions build up over time because there isn't a unified effort within a group that you're in. And I'd say that's particularly, for early career folks getting used to the environment, is like definitely be aware of the factions that may develop in an organization, what they want to do. And one of the things Gary kind of got to is the more entrenched those factions are and the less coherent the group is, there's sort of a ceiling on what's going to be happening in that case, and the more severe, it's kind of like I want to say calcification of arteries, or like things that are just going to inhibit the blood flow in a body, but it can be very severe and essentially limit that. So be very mindful um, on how that affects the potential of the situation you're in. Let's say. What was this here? This one was. I'm a little bit of a fan of what Brendan McCord and the Cosmos Institute are doing. Like they're trying to do all this philosophy builder stuff. I've commented on their stuff a few times, and I've applied to some of their stuff, but this is a bit more lofty stuff we can talk about elsewhere. But building and where we want to go, and my sense of direction. I've developed something called like destination discernment, or direction-based research, or direction-based leadership as well. So more on that later. And I just saw this earlier about apparently there's going to be a AI capabilities and alignment consensus project from Alicea that I just saw. So I don't know if this is like related to what we were doing before at all. I'm just looking at it for the first time now, but it seems the world model is related. And we'll look at that a bit later. But Adam's doing something that he just sort of teased on, collaborating with Michael Levin. Okay. Oh, I see. Yeah.
Yeah, I was talking to him about it, and it's basically a follow up to the special issue. So he's trying to like build out some intellectual development in that area. So this is just kind of another step in this. Plus, they got this grant from the through the Active Inference Institute, so they're doing this work on aligning AI and kind of figuring out what that means. Because it seems like it's a huge buzzword, but it doesn't necessarily map to a lot of meaty topics. It's just kind of like,
yeah, exactly. And there's a lot. I've recently seen some more interesting alignment talk from a group of people looking at like thick value alignment, and it's like, okay, what does that mean? Can they do it? But like, yes, I'll just say yes. That's, we can talk about that tomorrow or something. But any questions or comments on what I said before? I know it wasn't really the most clearest of sharing things beforehand, but my takeaway from this week in brief is it's been a huge week for me understanding the business aspect that surrounds a lot of what we're doing, even if it's open source, to be honest. But just what it is in sort of everything outside the code. Like this week has been huge for everything outside the code or outside the project itself. So more about that in the weeks to come too. And then also next week I think will be a good time to actually do the full go through the technical presentation report, because I've refined that a little bit. And if anybody still has questions or comments, I think I mentioned you guys too, or like Bradley or Morgan, if you have anything you want to say, let me know, and I'll try to do that. I've also asked a few other people, some people in person, some people I met in on some of the courses and discussions this week. So yeah.
I mean, I mentioned some things on Slack, and yeah, I mean I'm moving forward to the full presentation.
Yes. Okay.
I thought it was interesting that Andrew Feinberg, that was leading this workshop, also had a discussion with Michael Levin about their Anthrobot work and how that interfaces with kind of their tissue engineering. So again, I'll be able to say more about that next week. But yeah.
Yeah. Okay, I'm going to finish up today with a discussion on openwashing. This is something that we talked about open source and how to make your project open source, and then how to make it a hybrid project where you have both proprietary and open source components. And a lot of corporations or organizations that have a lot of proprietary interests will do this because they want to have open source, but they also need to keep things secure and private and all that. And so then this is the next step in the other direction, which is where people will sell something as open source, but it's actually not open source. There's a sort of it's mostly proprietary, or the open source component is trivial. So this is one article from InfoWorld from David Linthicum. This is on openwashing and the illusion of AI openness. And so this kind of talks about in this AI space how you see openwashing and how you can advertise things as open or open source when in fact it's not open or open source. Remember, we said that open source usually involves being able to manipulate the code, maybe through an API or through a GitHub repository, but also to have a license that's very clear in terms of maybe how you can fork a project and modify it, or how you can use it for your own purposes and modify it. There are a lot of ways you can approach open source, but sometimes companies will advertise themselves as open source, but it's not, it doesn't have license or doesn't have the access that you would expect. So cloud AI providers brag about their generative AI and large language models that are open, and enterprises are falling for it. And so this says that a peculiar trend has taken hold within the AI gold rush. Major players in the space, from OpenAI to Google and Microsoft, have started to invest heavily in marketing their AI models as open. These companies are using terms like OpenAI to align with notions of transparency, collaboration, and shared progress associated with open source software. So this is like, you can think of FOSS, or free and open source software, as a model for this. And of course, that's what we kind of expect, at least something similar to that. And of course, we don't get that because when they use the term open, it could mean something very different. And so in this case, openness seems to be largely performative. And this is what we refer to as openwashing, or just one of the ways in which we talk about openwashing. So in the AI space, openwashing refers to companies overstating their commitment to openness while keeping critical components proprietary. And so this is something that you see a lot with like corporate types of open source, where they'll give you something that's open. I guess you could use something or use an API to access a server with some of the critical components, the training weights and things like that. But those are all proprietary, and you can't touch those. You can't inspect those, and you certainly can't change them. So this is, kind of works against this expectation of open. But we've seen this before. We've seen cloud washing, AI washing, and some of the other ways in which concepts are sold without actually adhering to the actual concepts. So marketing firms want the concept of being open to put them in a virtuous category of companies that save baby seals from oil spills. I don't knock them, but let's not get too far over our skis, billion-dollar tech companies. So I guess there's this expectation of open source being aligned with a certain set of values. And of course, those may or may not be true. I think what he means by saving baby seals from oil spills, meaning that open source is somehow has this aspect of altruism that, is certainly true of some open source projects, but I don't think is necessarily always the case. As we said, you can do open source in a number of ways, some which are less virtuous than others, perhaps, but it's still, open washing is this sort of separate category. Although these companies claim their generative AI, large language models, and etc. are open to all, the reality is that these systems remain locked within frameworks controlled by the very same corporations. I think that's crucial, is that the frameworks are not allowed to evolve according to the contributors or according to the needs of users. It's kind of like within this corporate space, so you can access things, but you can't change them too much you're kind of limited as to how you can contribute to the projects, how you can modify them. And so sometimes instead of fostering genuine openness, this type of strategy frequently cements the concentration of power in the hands of a select few. What appears on the surface to be democratic and collaborative is, in practice, a polished marketing strategy to perpetuate control. This is wholly related to cloud computing, considering that many of these open-wash models exist on cloud providers and are built and sold by cloud providers as well. So, talk a little bit about open-washing in AI, which is where you can have, say, access to a model, but the critical aspects of systems, things such as data sets, infrastructures, training methods, and maybe even some of the more practical uses of large language models remain tightly guarded. These are not minor components, but the core elements that drive generative AI systems functionality, innovation potential, and scalability. And so this is, one example of this is where large language models are released under permissive licenses that claim anyone can use or adapt them. Indeed, this may appear to democratize AI, especially to less experienced developers or startups. However, these models often exclude access to critical features, such as complete training datasets or the computational power needed to replicate the models from scratch. So there is an interesting aside here is that, we have, say, like the MIT license, we have the Apache license, we have common licenses in open source. And a lot of those licenses allow you to do different things with the open product. So you can freely modify things. You can make a profit off of something. Depends on the license. Now, in generative AI, in that space, there are a separate set of licenses which are very specialized for generative AI. And they include a lot of the things that you might need that are very unique to that space. But, in this case, we're talking about corporations kind of controlling a lot of those components, not including them as terms of the license, or at least, not permitting you to use things. When they say permissive license, that might just simply be to use their product. So this is something that, again, the licensing aspect, I think, is key in terms of open washing. When you have a project or when you engage in a project, you should be clear on the terms of the license. And so, yes, again, openness, transparency, and reusability are sort of at the heart of open washing. And I think reusability is also an important aspect because, again, you want something that's interpretable, you want something that's repeatable, and we want something that we can use again and again and know kind of why we're getting the result we're getting. So that's this article, and you could read more about this article. I wanted to move on here to this Wikipedia definition of open washing just to kind of ground us in a common definition here. Open washing or openwashing, and it's based on words like whitewash or greenwash, where greenwash is where companies will say that they're doing something environmentally friendly when it's actually not as environmentally friendly as people think. Whitewash is just a term that means you make things look better than they are. And so this is a term that describes presenting something as open when it is not actually open. So in this case, open refers to transparency, access to information, participation, and knowledge sharing. So they include a few more things in that definition than the last article. The term itself was coined by Michelle Thorne, an internet and climate policy scholar, in 2009. Thorne used Berlin Partner as an example of open washing when their marketing campaign featured the slogan "Be Open, Be Free, Be Berlin," despite terms of use that can contradict principles of openness. So you can see how it sort of intersects with marketing, it sort of intersects with the identity of the organization, but then it doesn't really deliver on the open part. It just kind of takes that as part of that image, and people just kind of feel like it's open when it's not. In 2016, open washing was discussed at the Open Exchange for Social Change conference in Madrid. This familiarized international scholars to the term, but did not result in a universal or changed definition. Evgeny Morozov criticized the term open washing because of its failure to concretely define what openness means. Morozov argued that with many definitions of openness, open source, and open data, openwashing can be used in many contexts and help us question the authenticity of open initiatives, but does not indicate the barrier to openness itself. So this is an interesting critique of this idea, is that, sometimes we use it and say, well, companies aren't as open as they could be, but then we have to think about it in terms of what are our expectations. So often our expectations might be like the same expectations we hold for something like FOSS, which is free and open source software. Well, those organizations have different goals and different standards than large corporations. So the question is maybe do we expect that those same values from a corporation? And the answer might be no. But then they also might offer, enough to be an open source and enterprise. It's just scaled to what they're doing. So a large corporation has different goals and outcomes for their intellectual property, for their their projects within the organization than does a FOSS organization. So we should expect different standards. In any case, this is something, and I'm not saying that every corporation that does open source does openwashing. What I'm saying is that openwashing is a trap that you can fall into, or that corporations can use cynically to promote their own products. And you see this with AI, but you can see this with any other set of organizations as well. In the Wikipedia entry, they talk about openwashing by governments, where governments will advertise sort of this transparency as being good practice of democracy or good practice of serving its constituents, when in fact a lot of governments aren't as open as they claim to be, or they use that as a pretext for, this sort of ethical gold star that you can hold up and say, we're being transparent, when in fact you may not be. So that's a little bit about that. And then this last article is from Dick Reel's Industry and Research Publications. What is openwashing in software? So this is in the software community, not just in the AI community, but in software. So this talks about openwashing as a term used by proponents of community open source software against commercial open source companies. So this is where it kind of couches it as something that people in like FOSS organizations or nonprofit open source software organizations will use to contrast themselves with commercial open source companies or large corporations engaging in open source. The goal is to shame the companies into changing their business model, as well as to prevent the business model in the first place. The claim is that commercial open source companies may be providing open source software, but are not following proper open source principles, and hence are abusing the term open source to mislead users of their software. And so they claim the claimed abuse is that companies are tapping into the goodwill associated with the term open source software, build up community open projects without actually being community open source software. And so then proponents of community open source software assert that software should only be called open source software if they are communally developed and owned. This does not leave room for commercial vendors who tightly control the development of software they make available under an open source license, who do not accept community contributions unless their contributor transfers their copyright to the vendor, and who remain the sole owner of their software they build their businesses on. Commercial open source vendors typically maintain this control and ensure maximum flexibility in what they can charge customers for, as well as to keep competitors away. And so then this is basically sort of a culture war between these two types of organizations, and there are a lot of tensions in these different ways that open source is practiced. So this is just, again, just kind of highlighting this difference in perspective between different types of organizations, organizational cultures, and ultimately ways, maybe the way that a lot of corporations engage in open source is legitimate, maybe it's not, but we have to be aware of these differences in definitions. Okay, So I think that's it for today. That's all I had on that. Did we have any questions or comments?
I guess I'm not sure how to form this. My mind's a bit slow today, but I'm trying to get at not just like how can you ensure someone is doing open source stuff, but more like any like and this can be a broader discussion for another time, but sort of ways, high level or simple ways, or the main topic is like developing. I don't know what to call it other than like organizational literacy.
Yeah.
Like how do you understand what's really driving the organization's choices to implement or operate in certain ways? Like that's the real question, but like that's sort of like the magic question. Like, oh well, how why don't you know what the lotto numbers are? Like so I'm trying to think of a more tangible version, like ways to get people to understand what the organization is trying to do and things like that. But maybe I can form a better question next time if there's nothing to really say right now about it. Yeah.
Well, I think this is all stuff to think about long term, because I don't think people have a really good lock on precise definitions or what this means more broadly within organizations, and then reading organizations from the outside. What are the expectations?
Yeah. And I think to for just a little bit, even including to the McCord post and Hubby and Demis and the Twitter thing that I showed, I think we're in a moment where there is, and I want to find better ways to say this too, there is such competition for belief in doing things. And what I like about what McCord's trying to get at is like, you should think as a builder, where do you want things to go? Like he's not using destination orientation. That's sort of my approach on it. But like, where do you want things to go in terms of what you are building, like the choice to build the different ends, and how are you doing it, and bring this sort of not just being a consumer but a generator of direction in sort of medium, short, and longer term ends of the goal, and how you are constructing the organization and relating itself. And it's I think there's its own literacy to come around that, and I think that's maybe part of what I'm just moving in the dark towards fleshing out in all of my projects. Like, what is the literacy, and just preparing people to understand. Like, I really, my closing soapbox moment for today will be, I truly believe there's a massive disservice right now in education to. There's nothing in my undergraduate or graduate training from, R1 institutions. I was looking at like the Inventors Association or whatever, National Inventor Academy Association of Inventors. These are all like really highly rated people in these sort of metrics for doing stuff in the world. But there's so little acclamation towards what are the environment you're walking into. Like we're not preparing. It's kind of like my Vantage Points essay, which I don't know if I've published here or I've showed you, but we've talked, like, I think I've shown you in some form privately, but like the Vantage Points essay that I've written, where it's like we're training people to reinforcement learning and sort of this maybe hand waving stuff about some data ethics, but like we're not preparing people to, like, when you go into AI, which is moving at a very, very different pace than everything else, what do you understand? So I think I'm actually, I think almost like a series about this, like what is Openwashing? Like that should be something people know about when you're interfacing with an organization or being hired or doing interviews, like that's a thing. Like it's a thing that's out there, not just sort of, oh yeah, buyer beware, like, do you ethically consider it, but more like, no, like the talent wars, and not just Meta's $1 million purchasing, but the talent wars and getting belief. Like it's a really contested environment right now, and I don't think there's I don't think due diligence is being made to raise people to be aware of what's going on in that environment. So I'll leave it at that for today, and we can be more constructive about that next time.
All right. Well, yeah. Thanks for attending. See you next week.